Hello everyone. Hi. We're supposed to be live, so welcome to Code and Deploy. We are actually launching 2025 sessions. This is the first session of the year. In case you didn't see the show last year, this is a coding session, right? So we used to invite people from the community working with AI and to show what their projects or what they are doing. AI, data science, sometimes machine learning. Sometimes we'll be talking about agents. We have a lot of planning for this year. It's a monthly session, so this is February, and we'll be doing monthly, hopefully until December or November, but who knows how the year will be. So we are streaming live on LinkedIn and YouTube. Just let me know if you have any questions. You can interact with the chat. Let me know what your thoughts. I mean, we can make questions to the presenters. This show, I used to do it most of the time with one guest, usually, but now I have two guests. So this is actually awesome. We'll be talking about the first coding session of this year will be around a topic that is very interesting. When we are working with AI, it's okay. We love to deploy or to test our applications on, I don't know, Jupyter notebooks. We like to test it. We like to prove it and so on. But what happens when we actually go to a production environment? We need to worry about how the data is handled. How can I trust on the data that goes to the model and so on? And there is a very interesting topic and concept that is called data contracts. So I'm not the expert. So this is why we have two of the experts here. And let me introduce them to you. We have Jochen from INNOQ. Hi, Jochen. INNOQ.
Hi.
Yeah, thank you. Thanks for being here. And we have JGP, who is, hi, JGP. We met probably 5 months ago or 6 months ago. I've seen his presentation on ODCS. He actually talked about data contracts and the project, which is an open source project, by the way. So I'm very pleased to have you both here. So welcome, guys.
Thanks, Evie.
Thanks for inviting us.
So just to start, just let us know, can you introduce yourself? What is your role and what you're actually doing? We will start talking about the data contracts later, but I will first would like to know what you do in your companies and what you're actually doing, right? Jochen. Yeah, sorry, Jochen, you can go first, sorry.
Yeah. So I'm a tech lead at INNOQ. So INNOQ is a German consulting company. My background is software architecture and software engineering, so I'm not coming from data engineering very much, but bringing knowledge from software architecture to the data world. And here I'm maintainer and author of the Data Contract CLI tool, which we're going to look into today, later in the session.
Amazing. Thank you. JGP, you have someone that's saying
JGP
hi to you. You have someone that is saying hi to you. Depiner Kaur. Yeah.
JGP or Jean-Georges, depending on your level of French. Today I'm not representing my employer, but I'm presenting the Bitol project from the Linux Foundation. We are fostering and we're aiming at building modern data engineering standards. Among them, the data contract and ODCS, which is a really growing in popularity among practitioners. So, Jochen and I are part of the technical steering committee of this project, which is super democratic, and I'll explain a little bit about that in a few minutes.
Amazing. So let's first start to say what is a data contract? Why you actually need to worry about a data contract?
Right, so I can start this one, and I'm going to share my screen a little bit.
Okay.
I promise I will not try to be annoying with slides for too long. Okay, so I know nobody is here to watch slide. So I have a data contract you cannot refuse. Okay, and that's and to explain that, I want to go a little bit behind that, where we're saying, okay, well, I have everybody knows or should be knowing what a data pipeline is. But basically, it's a link between a producer and a consumer, and usually it comes with a part of transformation, a part of QA, and a part of documentation. Okay, I've been super lucky in my career to have always had documentation as part of the deliverable, but it's kind of it stays fresh for like a couple of days. Okay, so that's a little bit where the context is. But let me tell you a little bit about a story. And the first thing is I've got an older son. Is like in his early 20s, graduated from a master in computer science. He's a data engineer for a major bank. And once he called me, okay, so if you got old teenagers, late teenagers, and young adults, when they call you, usually it's not a good sign. And when he called me, it was, hey, I've got this report and it didn't go out. It was an important report. I'm sure I'm going to lose my job. It was kind of 3 months in the job, and my consumers are not happy. And so I tell, okay, well, what happened? He told me, well, I'm in charge of this data pipeline that brings the data from an ascending system. Usually it's okay. Now, poof, no more data. It's as we say in German, kaputt gegangen. And the thing is, basically, he said, okay, well, there was a problem after the root cause analysis. The upstream system was down, and basically, what I told him, but if you had the data contracts year and year, okay, you would actually be able to avoid all these issues. So here is. What is a data contract? Okay, so it's really about creating a link between a data producer and data consumers. Okay, it's also creating a link, and that's a very important distinction and a very important feature for our friends in data governance, between the business part and the technology's implementation of the data itself. And for me, it describes also something I call the metadata. So it's not a typo here. It's really about also, we all know what metadata is, okay? Column names, field names, lengths, etc. But the metadata is about the behavior of the data, about the quality of the data, and all the rules you can, whether technical or business rules, you can actually apply to that. And that's something which is really important. So as a result of that, when you're looking at these three features, what we can define as well is say that the data contract is really the source of truth for your metadata. Okay, in our industry, we're very often looking at what the source of truth for data is, but we forget that the metadata is also a source of truth. So a little over a year ago, we went with a data contract standard, with something I created with my team back at PayPal before, and we went to the Linux Foundation and we created the Open Data Contract Standard, and that was in November of 2023. In November of 2024, we went to the next level, which is incubation level at the Linux Foundation. So that's out of a three, we're kind of the middle tier now. The contract itself is you measure popularity with a number of stars. When we started at PayPal, it was anything that a major company is publishing gets instant recognition, right? But ODCS took a little bit more time, and we are now at 444 stars. But what is really important is that from the 5 contributors who were on my team when I was at PayPal, we went to more than 38 contributors that are actively participating in developing the standard, and that's huge. In terms of governance, which is something that is really important, is that the TSC, so the Technical Steering Committee, where Jochen and I are part of, but it's also 14 different people with 14 different perspectives on how we can actually drive this thing. And it's representing 13 companies. And the thing is, what's really important to me is that you see the repetition, okay? So you see four companies in consulting, 5 that are users, okay, like the company I work for, and 5 are vendors, like the companies that Jochen is working for. But the thing is, we get together in that to not dominate. There's not a dominator, like a vendor dominated something. It's really something that we work around together. And then you've got the working group, and then you've got the users the active users in the community that come to talk to us. And for that, the data contracts for me is the first step. We're going to talk mostly about data contracts today, because it allows you to do a better documentation, better data quality on SLAs, and faster discoverability. But the next stage of the rocket is really about data product, and eventually you go further and you go to data mesh. But the idea of this approach to data engineering and data management these days is that you get instant value at every step of the way, compared to, I would say, a Snowflake implementation. Okay, I'm not picking on Snowflake, but the thing is, you get results long time after you actually do that. When you do data contracts, data products, and data mesh, you've got kind of almost instant gratification. So that was kind of my intro. Easy, if happy to answer questions.
Yes. Yeah, no, thank you.
Yeah.
Thank you. And also, the audience, if you have any questions, please put it in the chat. I do have a question, which is about, you mentioned that you started the project with just 5 contributors, right? And it was moved to 30 or 40 contributors. So
Correct.
the first question is, how did you do that? How you got 40 contributors or maintainers? And the second question is, it's probably around what you'll be doing open sourcing this. I mean, what is the actual value that you see when you are actually open sourcing this, like the project?
Well, so I think it's an open standard. For me, open standard is even stronger than open source, because you can build a commercial application based on those standards, and we've got a few examples, and you can build open source applications like the ones that Jochen is going to present. So it's really it's an overarching thing. It's like HTML. Imagine HTML if it was a proprietary standard, the web would not be where it is now if that was the case, right? So I think that's a lot of people that are part of our group. I've understood that it actually matters to create this next generation of tooling, or this next generation of thinking in data engineering. But if you don't go through the step of standardizing what you're doing, and you go directly like, oh, I'm going to build the data contract implementation, you've got 5 or 6 different vendors that are not compatible with one another.
Okay, great. We have a question in the chat saying, can you please expand a bit more on data products?
Okay, so that's a great thing, and I love data products. Okay, so I think that the idea of what we were trying to do with Bitol is set up the foundation with ODCS, the Open Data Contract Standard, and now we are kind of moving towards the definition of more what a data product is. Okay, and we have actually. I was at Data Day Texas back in the end of January, and with a group of people, we got in a room, we discussed. There was 40 people. There was like 20 people from product management, 20 people from data engineering, and we got together and we really tried to carve a definition, and we posted it on Medium, and then we relate it on Wikipedia, and that's now the definition on Wikipedia of what a data product is. So I'm not going to cite it. It's a little bit lengthy, but the thing is, the data product is really about creating reusable assets that are standardized on for faster discovery, for faster reusability, for increased trust in the data. It can be as simple as a data set, and it can be as complex as multiple data sets with multiple versions, with models, with agents, all that inside. Okay, so a data product is really, I hate the term container, but it's a kind of a super container, a very smart container that has data artifacts that distributes that can be used. Okay, so that's there. So I don't know if you've got any more precise question about data products, but that's the idea.
Maybe something to add. What I like to explain is, so I usually see a data contract as an interface, like an API, and a data product is implementing this interface's data contract, and it could implement on one data contract or multiple data contracts. So the data product is providing the actual data sets over its output ports that are implementing the interface of a data contract.
Amazing, amazing. So, who made the question? Dip in there. Just let us know if it answered your question. For me, it was clear, but let us know if you have any follow-up question about that. All right, great. So, one more question before moving to the actual example. I don't want to take much of our time of the deployment part, actually. What would be like a very simple example? You actually explained what is a data product, what is a data contract, but how would be, for instance, if we are training a machine learning model where I have my data from customers, whatever, what would be the importance of having a data contract, and what would be a data contract in that same, or at least one example, right, to say what will be a data contract, what will be a data product?
I take a first stab, and Jochen, if you want to take after. So we know that when you've got an LLM, okay, or when you've got a model, the data you're feeding to your model is critical, and the quality of your data is critical. Okay, I've heard people saying nonsense like, "Oh, with AI, I don't need data." That's pretty much also okay. So the data contract, and we didn't, because I didn't want to spend all this time on what is the content of a data contract or a data product. But for example, a data contract has a schema inside that is really clearly describing what kind of data and the quality of the data you're going to feed to the system. So if you're in the case of training data, for example, well, on training getting more and more pricey, okay, you want to make sure that what you get in your system is actually matching what you expect. Okay, so the contract can guarantee these things. Okay, that the values are within a specific range, that you have not null values we're expecting, etc., etc. So you can describe that using ODCS directly on the schema as a center part of the contract, and then your LLM can actually learn from that. Okay, and I've played with some LLMs, giving them the structure of a data contract, and they kind of understand the YAML format like a human would understand it, and can actually explain that. And I know that Jochen also did some work on this field. So when it goes, that's for training, but when you can imagine that if it's about feeding, for example, a RAG, okay, and guaranteeing that your RAG has the right data, same thing here, right? The thing is, you want very high quality data, and that is matching your or representing your company. Okay, so that's also something that is, for me, very important to mention there.
It is, and one of the questions I always have when we are presenting like RAG applications or chatbot applications with the RAG is, how can we be sure that the data that we are ingesting in our RAG, providing the context, can be secure from one side, but on the other side, how I can be sure that this is standardized, how we send that data to the LLM to answer. All right. Great. I don't know if you're ready to show something or to actually go to the code. You have 35 minutes. So, Jochen.
I stop sharing.
All right. Thank you, JGP. You will be around here, so don't leave. I mean, stay here. We will make you some questions too. Thank you.
Okay, now, maybe let's create a data contract altogether. So please join me and let me share my screen. I want to share my screen here. And before we go into the data contract CLI, which we'll use later to test the data contract we're building and generate code out of it, let's start with crafting our first data contract. So let me create a new file, and let's say this is our ODCS YAML file. So data contract is a YAML document. Everything is YAML today, so data contract is a YAML document as well. And let's start with some fundamentals. So let's start with the API version. So we were using latest version is 3.0.1 of a data contract, and we define data contract. Well, this is how to begin it. Now, what kind of data contract do you want to build? And interesting thing is, when we do consulting about data products and their contracts, we want to start from the business case, from the use case. So we are usually inviting data consumers and data providers into one common meeting and discuss the business case. So for example, today I brought a data consumer, I brought Sophia, who's a data scientist, and she has some requirements. She wants some data from another team. So our business case would be, in our example here, is that Sophia, as a data scientist in team recommendations in like an online shop, she wants to get all web shop orders from the past 5 years, so that they know which articles or article categories are often bought together by one customer. And with that, they want to create an ML model to generate individual recommendations for the customers in like marketing emails based on the recent activities in the online shop. Right? So we can use this user story now, this requirement now, to define the expectations and requirements for for data sets that another team, like John, the product owner of team checkout, who is responsible for the orders data in the system, can provide. So what we do is we, together with Sophia and John, draft the data contract. Now let's start with saying, okay, you want the orders data, so you probably need a data product for orders. And so we get an ID, and we want to give a name, and let's say this is web shop orders. And what we start with a status, which is like proposed. So this is not how the actual data currently looks like, but how the data product should look like when it's implemented. So we can start contract first. We could also start data first if there is already an orders data available. We could also start data first. But now let's start requirements driven. So we have some more information, like defining the domain. So domain is maybe something like web shop, where the data is coming from. And now let's start with the schema. That's the core of a data contract, certainly is a schema. And the schema should contain a table, and the table name is probably something like, well, orders might be a table name, which is a table. So the physical type is table. It's kind of obvious and some here to define. But what's certainly more important is the semantics of the orders table. So even if it's kind of clear that it's orders, which are probably web shop orders as we have the domain, it still makes a lot of sense to define the semantics and description of this table here. So what could it be? It contains an entry for every successful order in the web shop. Okay, so now we get some semantics because it means we only have successful orders, but not failed or canceled orders, right? So this is something that is relevant for a data consumer to know, to understand if there are only successful orders, which might be relevant for KPIs, or if there are also some orders that may be canceled that need to be filtered out. And we could even say, since like adding a date, so it's only orders that are in the system since 1st January of 2020, right? So this is maybe also an interesting information for a data consumer. And now what we define the contract further is the column structure of this table here, right? So let's maybe add one or two structures here, and we get here completion, but let's start simply with a name. So we certainly have a property, a column that's called order ID. And so this is a technical name, but we could also define a business name. So what is the business name of an order ID? It might be something like order number or order ID or XYZ ID. So let's use the language that the business is using here, put it in here, so we have a translation from the business model to the technical model here as well. And we can go on. So next thing you typically see is something like a logical and a physical type. So the logical type of an order ID might be an integer or a string. So we're using the JSON schema types. Here for logical types, you could add some logical type options, so like defining a min length or max length. So let's assume in our domain, a order ID always has a fixed length of like 10 characters, right? And also let's define the physical type in our database. So maybe in the database, we have a varchar document here. Now we have the column name and the type. Now don't forget the description. So the description for order ID might be super simple. So let's simply add unique identifier for the order. And always work with examples. So if we have an example that shows like a UUID, which might not be the things that a business consumer is expecting here, because in our companies, like order IDs look like this, right? So you would get immediate feedback from your domain experts that say, oh no, this is not what an order ID looks like, right? So always work with examples, which make it super easy to discuss if the expectations we have here are in line with the business, right? And we said it should have a fixed length of 10. So now make sure the example is in line with the format information here. Okay, what else do we have? We have information about, is it a primary key or not? We can say, oh, it's a unique field. So yes, this column is unique. And we can also add data governance information, like is this a restricted or public field? Okay, let's say this is a restricted field, could also be a public field as it's shown to the customer as well, but look, put it restricted here. And we can also add some more tags that are often used with governance, like this might be an PRI information or not. Okay, so these are some of the core fields that we usually define for every column we have in our tables, right? And let's do one more. Maybe let's do quickly an order total. So the order total might be a logical type number and a physical as a physical type, which is number as well. And it might have a description. And of course, we have examples here. And here, maybe it's important to understand that it can contain decimal places here with the order total. So this again is a required field. So there's no order in the system without a order total. And now let's add something kind of interesting, which is quality. Right? So as JGP mentioned, we don't only have the structure of our data schema, we can also define quality attributes and quality expectations. So in collaboration with our domain experts like Sophia or John, who know pretty much how the data looks like or what they expect from a particular data set, we can define quality guarantees. And we can use it in plain text using the description saying the total amount of the order should or is expected to be greater than 0. So this might be a simple quality attribute, but we could also do something like it should be greater than $50 in 59% of all orders, right? So having really some kind of business expectations that can be expressed here. Now, we want to make these quality attributes testable and executable, right? So we want to make sure that the data we're getting is really valid and conforms to the quality attributes here as well. So what we could do is we could translate this text quality attribute to a SQL data quality rule, and so we can define like a SQL statement that can be executed and compare with a table later on to work with it. So we can make it simple at the beginning. So we can make sure that the statement is executed. And what we do in data quality testing usually is we compare or we calculate a number and make sure that the number, which often is a count, matches a threshold, and mostly we compare must be to 0, right? So we want, let's make it simple, select count from orders where order total is smaller or less than or equal to 50. And let's make it simple for the beginning. So what we do here is like a data quality check or JUnit test for data is we count all entries in our database which are not compliant to our expectations. And if there is a result that's greater than 0, something is wrong with our data. Okay, so this is how data quality checks typically work. Okay. So this is how a data contract looks like. And we would do this exercise here for all the fields, also properties in our data set, and we can even have multiple tables in our contract. So before we go to the next step in testing this thing here, Eze or JGP, any questions or additions right here?
So you basically define the structure of this, of how you'll be using or the orders contract.
So it's not only the structure, right? We have the structure with the column names and column types.
Mm-hmm.
We have the semantics in the description, and we have the data quality, the expected data quality. Yeah.
The data quality is very interesting. I mean, because you are actually comparing if the data that goes here, we are comparing you are comparing that with what you have. Yeah.
Exactly. So, and this is, well, it's not a unit test, but it's a like consumer-driven contract test, basically, right? So we test the interface, the data set that is exposed to our data consumers. Yeah.
Nice, cool.
And as you can see here, Easy, the thing is we're abstract from any tools, right? Any tools that can actually use a SQL statement, which is thousands of them, can actually use that. We're not depending on an infrastructure. We're not dependent on a set of tools. That's where the open standard rules as well is that it's not driven by one vendor, even if a vendor is demoing something right now.
And the types you can use, I mean, I imagine it's SQL, but what is another type of quality test that you can do, for example?
Yeah, so as we can see here, we have tags where you start with your business definitions. We are, for next release of ODCS, we're working for a library of predefined tests. So quality checks that we see quite often by the community. And you can also state custom quality checks that you can use in your current existing data quality engines like Great Expectations or Soda, if you use any of these.
Yeah. That's amazing. Yeah.
Okay. Now, before we go into testing, one more thing that's really kind of important is, so we now know the structure. A data consumer can look at it, can evaluate if it's okay for the business case. But let's go back to our example. So we have the user story from Sophia, and yeah, so he's asking for the data, the orders, but now John has a point. He says, yeah, okay, but well, actually, we cannot give you all orders that we have in our systems, but only the orders when the customer expressed their consent for analytical use. And in your ML use case, this is an analytical use case. So we can only give you a portion of the orders where the customer expressed the consent. And this is true for around 80% of all orders. Right? So Sophia can say, yeah, that's good to know. And that's okay for us. So, but it's important to state that the provided order set might not be complete. And this is something we can add to the data contract as well. So let's add it. So we have a field here like description, where we can say the purpose of this data set is this data set or data product can be used for analytical and ML or AI use cases. So this is okay, but we can also state the limitations, like saying, do not use to calculate like financial KPIs is the data that is not complete. And also, let's add it to the description here. Only orders are included when the customer consented for analytical use. This data set is not complete or does not contain all orders. So you get the idea here, right? So we can define the expected and allowed usage and purpose for the consumers, but also we can state the limitations what a consumer is not expected to do with the data, right? And this is something you cannot see if you just look at your data warehouse tables and just look into the data you have. you don't see that it's an incomplete data set. Right? Okay, now let's continue a little bit, and now let's play with the Data Contract CLI tool. So we believe, and the reason why we created the Data Contract CLI tool as an open source tool is we believe that it's important to provide a business value or a value for data engineers to define these metadata, these YAML structures in the long run. Right? So defining a metadata structure, defining this data contract YAML might be a job no one really likes to do, and nobody really likes to maintain just for the purpose of having a YAML document. So the idea is to provide a long-term value, a benefit for data engineers to make sure that this data contract is up to date with the data products. And the idea was, yeah, let's do something to test the data products or to test the data contracts, just like we have done with unit tests and integration tests, to get confidence in the data we are providing. Right? So the idea with data contract CLI was we want to do something like data contract test and make sure that the data we are having in our data warehouse or data lake in our data platform is in line with the data contract specification here. And for this, we need to define where the data is living, right? So until now, we are just defining the structure of the data, but we did not say, oh, this data is provided in Snowflake or in BigQuery or in S3 bucket. So let's add it to the data contract, and I'm copying right now. So let's add a server section. So in the server section, we can say we are providing this data as a data product, like for production on a Snowflake data platform, could also be a Databricks source, BigQuery, you name it. And we have it in this account, in this database, and in this schema. So we have all the information we know where the data is living. So the data contract CLI, what it does, it connects to this database and looks if all the structure and quality expectations defined in here are in line with the contract. So let's quickly look into Snowflake. So now I prepared a data product, which might be a process of some weeks or something for the data engineering team to build a product that is in line with the contract requirements. And we now see here, okay, we have a table orders, which contains an order ID, contains an order total, and maybe some other fields that are defining contract. Plus, there's a second table, like line items, which provides the individual positions of the order. Okay, so now we have a data product.
Sorry, can you make this a bit bigger? I know that it's not important actually to see what is the field. Yeah, that's great. Yeah, thank you.
Okay. So this could be our data product now, orders, and it's providing data like we see here in this example with the order ID and the order total. Okay. Nice. The credentials for connecting to Snowflake are in environment variables, which I prepared at the beginning. So we have a user, we have a password defined as environment variables. And now let's look what happens when we test our data contract we just created. So I'm now in the terminal here using Data Contract CLI. And what it does is it's generating individual checks internally there are SQL queries, and we have some checks if also fields are present, of the types are correct, so it matches the physical type. We have some checks for uniqueness and some other guarantees we define, and we also have checks for the data quality statement we have here, and we now see that the data quality check fails. So we have 293 orders which have order total less than 50, right? So this would complain. We get an exit code which is not 0, so we can use the data contract CLI in our deployment pipelines to break the pipeline or to get a warning to inform the data engineers that something is wrong with the data set. Please fix it before it goes into production. Okay, now let's fix it, and let's fix it by changing the quality statement, which was probably not correct. And now let's test again, and now we get a green test result here. Okay, so we can use this data contract testing in our continuous delivery pipeline, in our deployment pipelines when we deploy our data product source code or data pipelines or Airflow jobs, whatever we use to build data products, and make sure that we guarantee the quality and the structure that is defined in the contract interface.
I have one question that actually was a few minutes ago, but I think that's good to also answer here in the streaming, which is, I think I can put it here. Oh, yes. From an industry perspective, an industry standard, can data quality portion be optional as well? From adoption perspective, will users be really worrying about data quality as a beginning step?
Well, the question is if data quality can be optional?
Yes, I think that she's referring about not worrying on that at the beginning, because at the beginning, probably when they are deploying that, it's not what she's saying. I think that it goes around that, the question.
Yeah, absolutely. Absolutely, it can be optional. We even recommend to start with plain text, which will not be checked by the CLI tool, but you can define the business expectations or guarantees in plain text for the beginning, and later when you're more confident in what you have, you can change it to an executable data quality check.
So this is like, JGP said there, it's like a living document, right? So you can actually be adapting and make it growing or adapting it.
And it's like source code, okay? Or in your application, when you have your application, you start usually with a minimum test of your input and things like that, and then after a few bugs and things like that, you keep adding test and test and test and test. Okay, so here you can see exactly the same thing. Okay, oh, it failed. Oh, I did not have this test. I'm going to put this test, or your SLAs, okay, your service level are changing, and it has an impact also on that. So it's a really living document, and that's I think that's what's defining this new modern data engineering, or this new phase of data engineering we're facing, is this iterative process compared to the very project-centric way of doing things not that long ago.
And maybe one more thing we could show here quickly, I think we have a few minutes left, is we can even add SLA definitions. So we can not only define the quality and structure, but also non-functional guarantees, basically service levels, like, for example, like freshness, where we can define, okay, we guarantee a freshness of the data. So the maximum duration from when the order has happened in real life until the data is available in our data platform is, like a maximum of, either like 5 minutes in a streaming application or 25 hours in a more batch-oriented way. Maybe let's be a little bit more down and say, okay, we want to have a guarantee of freshness of like 5 minutes. And we even can check it when we define, like, we can compare to the order, like timestamp field in the schema above. So we can compare the current timestamp with the value of the order timestamp in our table, and that must be at least one entry which is younger than 5 minutes, right?
Amazing.
So this is something we could also check using tools like the CLI tool.
Amazing. Amazing. I have one more question. How do you see this? Because I'm thinking on probably the developer or the company that would like to adopt this. How they can adopt them in their pipeline, actually. How and where does it fit within the entire pipeline that they might have?
Yeah. So, as mentioned, we actually recommend starting using this kind of structured YAML document, which is human readable for the beginning for the requirements process. So it's a tool to foster collaboration between data teams, right? Which is kind of powerful. But as soon as you have your data products implemented and you have consumers using this data set, you want to have a data contract testing continuously with your monitoring tools and with every change you do to your data product code.
Nice. Nice. All right,
I think
yeah, sure. Go ahead. Sorry.
Yeah, so, sorry, I just wanted to add something to Jochen, because all what you've seen here on the command line, okay, you can have that in your CI/CD, okay. So the thing is, if you're making a modification and it goes against your data contract, okay, well, you can reject. You can reject the pull request or things like that. It's you're using this kind of technique that were only for software, but now you can put them also in place with data. That's also very powerful.
It is, and thank you for that. Yes, I mean for the CI/CD, it's very powerful. It is absolutely.
And maybe one more thing to show is we don't only have the testing command, we also have a export command. So we can use the meta structure we have here to export to really a number of different formats, like SQL to generate code out of the metadata. So, for example, we can generate a create table statement, DDL, from the metadata we have here. Or we can generate, what else do we have? JSON schema. So if you're using a JSON-based JavaScript application, you probably want to have a JSON schema for this metadata. Or you can use it to publish the metadata to other metadata technology like data catalogs, and have your source of truth for metadata here in this YAML document, which is owned by the providing team.
This is amazing. This is amazing. I mean, I appreciate. I love to have something that we don't talk about LLMs, right? So it would be great to have a more actual deployment CI/CD topic. So I really appreciate your time. One more comment is if you can or if you want to add, if people would like to be involved in this project, where they can go, because you probably seen him every time, right? So people say, okay, I would like to be involved. Where should I go, or what should I need, or what does the project need in terms of collaborations and contributors?
So it's a living project, okay? So, and it really depends. I get this question pretty often,
Yeah.
and you can, of course, you can go to bitol.io, okay? So that's where we are. At the bottom, you will find a link to our GitHub. Everything is running in GitHub these days, and our conversation is in Slack. So we'll also have an invitation to Slack to join our and you can have a user channel, you've got a working group channel, and you've got the TSC channel, which is private. But the two others is really, if you're interested in that, but you don't really know, is just go there, introduce yourself, okay, and we'll take it from there. And if you're a little shy, or if you want to, don't go public right away. My LinkedIn page, and I'm sure your LinkedIn page, is also completely available there. So feel free to reach out, and we haven't eaten anyone so far, I think.
No, I mean, at least not publicly, right? But yes.
Not publicly. Yeah, let's be fair.
No, but this is great. This is great. All right, we'll be posting this with both links and with all your information. So if you want to reach you out, we'll also be giving your both contacts so people can reach you out if they have any questions or they would like to know more about the project and to be involved, which is pretty awesome. So anything, we have 2 more minutes left. So any final words that you would like to add before ramping up?
It's easier than you think. It looks like a lot of work, especially when you're looking at all the details, like oh, I've got to do this YAML file, etc. Data Contract CLI that Jochen demonstrated has a lot of features to get started really quickly. A few bugs I also shared with him.
Oh yeah, show your book. I mean, yes, you have a book about it. Yes.
Oh, yeah. So I've read a couple of books. Okay, so this one I don't know if it's actually reverse or not.
No, it's fine. No, it's fine. It's fine.
And my favorite thing is I've read books for kids as well, and the books for the kids the books for the kids. More than half of the profits are going to 2 organizations that I support here in the US. One is Girls Who Code, and the other one is Black Girls Code, which is really about empowering women in the field of computer science and computer engineering. So you're doing good by buying them.
Amazing. All right. Thank you so much for your time. I really appreciate you spending 1 hour explaining, taking your time, creating a great demo. So I really appreciate that. So thank you for your time. Thank you for the audience also. They made a great question, some great questions. So for you, thank you both. We appreciate it. And for the audience, we'll see you probably next month. With a topic that we will be revealing, probably agents, who knows. Anyways, thanks so much, and see